Hello and welcome to the CoreWar Nano Challenge. I'm Inversed and I'm super happy to bring you this stream. I've been planning this challenge for a long time and we're finally here. Please let me know in the chat how is the sound. Is the stream working properly? Okay, the stream is working. Excellent. Hi Tia, hi Telclar. I'm honestly overwhelmed by the amount of entries I got because CoreWar is a very niche game and I thought that just a couple of old players would send their entries and that would be the challenge, but I got 23 entries, a total of 23 entries plus 2 of my own, so this is a huge success already. Hi John. And I'm going to start the stream by introducing CoreWar, just quickly skimming over what CoreWar is for those who just randomly tuned in. Let me switch to the presentation. Okay. Yeah, that's the right slide. So CoreWar is one of the oldest programming games dating back to 1984, and it's a battle of programs, assembly-like programs specifically. The players write assembly-like programs and they battle each other in virtual memory. The language is assembly-like and it's very minimalistic with only 16 operators plus some modifiers and addressation modes. So if you want to learn more, I suggest you visit these sites. These links are also in the video description down below. And this challenge is all about Nash equilibrium. Nash equilibrium, it's an important notion from game theory, and informally speaking, it is the best possible combination, a mixture of strategies that rational players could play. And if all players play the Nash equilibrium, then no player is able to benefit by deviating from the equilibrium strategy. And in CoreWar, we're specifically interested in a symmetric equilibrium of a symmetric two-player game, because that's what CoreWar is, if we restrict ourselves to 1v1 matches at least. And on the mathematical side, Nash equilibrium is a vector of probabilities. It's a distribution over strategies. And if S is our score matrix, then P is a Nash equilibrium if the score of any potential strategy Q against the equilibrium is not an improvement. It's less or equal than the score of the equilibrium against itself. So in informal terms, there is no better candidate on Nash equilibrium than the Nash equilibrium itself. It is, in a sense, the strongest mixture of strategies. What do we need to know about Nash equilibrium? Every finite symmetric game has a symmetric Nash equilibrium, so at least one equilibrium exists. The problem is that it is potentially non-unique, and before this tournament I've been trying really hard to verify the uniqueness of Nash equilibrium for CoreWar. I couldn't do it. I think it could be done computationally, with powerful mixed integer linear programming solvers with commercial ones. I don't have access to them, but I think it could be done in principles. But my conclusion is that it's very, very unlikely that CoreWar matrices actually have multiple Nash equilibria. And another notion I will be using is a zero diagonal Nash equilibrium. This is not a notion from game theory. It's just a variant of Nash equilibrium that I invented for CoreWar specifically, because the Nash equilibrium is typically very narrow. We have hundreds of strategies for the Nano hill. We have more than 1,000 for the 94 knob hill. And Nash equilibrium, it's just typically a few dozens of strategies. That's it. It's very narrow. So to make it wider, we can set the diagonal elements of the score matrix to 0 and calculate the Nash equilibrium of the resulting matrix. And it effectively penalizes high probability warriors and makes equilibrium more diverse. And the point in zero diagonal Nash equilibrium is to have a diverse set that's more predictive of the actual warrior performance against out of distribution warriors, against threats it hasn't been optimized before. Okay, let's move to the rules. Okay. Just a second. So first comes the qualification stage. We score all entries against the Nash equilibrium snapshot from the beginning of May, and all entries have to beat Nash equilibrium, and they have to beat it by a slight margin. They have to score at least 146 points to advance to the next stage. Okay, and in the final stage, the advancing entries are added to the snapshot of CoreNX2 Nano Warrior Archive, and we calculate the new equilibrium. And just to be sure, I'll probably calculate it multiple times with an alternative method. It's a slower method, but still. And finally, the players are ranked by the total Nash equilibrium probability of their advancing entries. First $100 first prize, $30. Oh, did I? What? $100 first prize, right? $30 second place prize. Okay, let's move on to the entries. I will go over all the entries one by one, so we're in for the long haul. You may want to grab a cup of tea. First entry is 21.5 by N-N. He sent this entry like 3 days after the announcement. He was the first one. It's a land for clear, and unfortunately it does not qualify. As you can see, the Nash equilibrium score is 136. Zero diagonal Nash equilibrium score is similar, but this number is just for reference. The only thing you need to qualify is to beat the Nash equilibrium threshold, the qualification score of 146. It's okay, a decent score, but not enough to qualify, unfortunately. And on the next slide, I'd like to show you the execution trace. I recently added a feature to Asia Mars, and now I can produce these execution traces, and I think it's really a neat feature for Nano Warriors specifically. It's a nice visualization of how the warrior works. And for 21.5, we can see a fairly typical nano clear structure. It's a two-pronged move attack. The crosses axis denote the move targets, so there are two attack streams, and minuses and pluses denote increments and decrements. And here's the initial warrior position, and the @ sign denotes the current process. So we can see the typical clear structure here. Alright, moving on to the entries sent by Dragonator, Evolver Nano 151282. It's a strange looking structure. We can see it starts at the second split. Here's the attack move, and then there's a DGN, which pretends to be a loop, but this is actually not a loop. As you can see, it jumps to a decrement 2, so it's basically splits all over itself and then beyond into the empty core. And honestly, it's not too surprising that the score is not very high, because this strategy rarely does well. Okay, here's how it works. We can see the attack stream and the decrement stream, but the core coverage is just not very high if we compare it to some other nano clears. Okay, the next warrior by Dragonator. It's basically the same warrior with just slightly different field values. Okay, let me check the chat for a second. Okay, nothing new here. And yeah, it's very similar, and the score is unfortunately not enough, but already we can see some ways to improve it, because the final instruction, that data instruction, that it's simply not used, and the initial SPL instruction, it's also mostly unused, because the execution starts at address 1. So Dragonator basically handicapped himself by playing for with a 3 instruction limit. And the execution trace is basically the same. Next, moving on to Kurogi, another newcomer. The warrior is called Asterion, and it's a double split, imp kind of move, then another split away to the imp, and then jump somewhere. Again, 106.7 points, that's not enough to qualify. Let's look at the execution trace. We can see that this stuff is pretty slow. Here's the imp attack, and here comes the splits, exclamation mark designates the split target. And yeah, the core coverage is just not enough to be competitive. But we have another entry by Kurogi. We have Karlach, which also features a bunch of splits, but works much better And it does in fact qualify, and it qualifies quite easily, 154 points. That's more than enough to qualify, so congrats to Kurogi for moving on to the final stage. The warrior is pretty interesting, I think. It's a kind of imp launcher. And it beats some of the warriors from the Nash Equilibrium really hard. And not a lot of warriors can beat it in turn, so it's a kind of a defensive strategy. Moving on to the execution trace, we see here's the imp, the move attack. Here comes the splits, and it splits to this location, and later jumps also to this location. So kind of a strange looking imp launcher. Moving on to lane. The first warrior, Gazette, is a typical nano paper. It's a very popular nano replicator structure, and it's a strong one. This structure is an easy choice because it's a very strong structure. It's easy to optimize, and yeah, it basically guarantees you qualification if you optimize it a little. Nash equilibrium score 159.7. Very nice, very impressive score. So lane's Gazette moves on to the final round. Okay, here's the execution trace. These replicators have very interesting looking execution traces. We have the first copy at this position. Then we have second copy at this position. And by around 40 cycles, we have a third copy that starts to emerge. Next warrior by lane, Conduit. It's a traditional 5-line clear. Also qualifies. All around decent scores. Not beaten too hard by many warriors. Also has a kind of imp-like attack, a move instruction that moves itself. Okay, that's an interesting looking execution trace. We have again a 3-pronged move attack, 1, 2, 3, and 1 decrement stream. Moving on to Telk Car, Discrete Foghorn. It's kind of clear, I think, but for some reason it uses an add instruction instead of a move instruction for attack. Nash equilibrium score is 120. That's not enough to qualify, unfortunately. Here's the execution trace. Yeah, you can see that the core coverage by cycle 40, it's just not enough to be competitive. Next entry by Telkar, Eventuality of Gods. That's a profound sounding name. This is, I don't even remember what this is. This is a kind of a clear with an imp attack. So here's the imp attack, and here's the split that probably splits to the imp. Again, 131.7, not enough to qualify, unfortunately. but I think it's an interesting try, an interesting warrior. Let's take a look. Okay, here's a self-moving move attack. Here comes the splits. The problem with this warrior is, again, the last dot instruction that does basically nothing. So you are handicapping yourself by playing with just 4 instructions instead of 5. The simplest thing to do is to just change dot to move and move it to the top of the warrior. So it would be one instruction quick bomb. And another idea is to remove the dot and add an attacking move instruction inside of a warrior. I think something interesting may come of it. Okay, next, moving on to Steve Gunnell, a long-time CoreWar player, but I think he's new to Nano. I haven't seen him playing Nano before. The first entry, Gem Tumor, is a clear, typical 5-line clear, but unfortunately does not quite qualify, just by the thinnest margin, by 1.3 points. That's unfortunate. The execution trace looks okay. Again, 3-pronged move attack and 1 decrement stream and 1 increment stream. The next entry by Steve Gunnell is Vilifier. It's a replicator, and by the looks of it, Steve tried to optimize it manually. I'm really not sure why he's using the same constants in 3 places, because for a nano replicator, these are typically different numbers, different constants. You want to optimize them separately, maybe just to simplify the optimization. And unfortunately, the Nash equilibrium score is not enough to qualify. The execution trace looks pretty much like a typical nano paper. Moving on to S. Fernandez. She sent an unusual nano replicator, a less common replicator structure, which starts with a 1 instruction quick bomb and then goes as a 4-line replicator. So respect to Sandra for sending less common paper variant instead of going the easy way. It does qualify quite easily. Okay, here's the execution trace. And we can already spot the difference with the other more common paper structure, because the initial replication is faster, the time to complete first copy is faster, because the paper is only 4 lines long, and at 15 cycles the first copy is fully complete. But we can also see the problem with this replicator design, because at 40 cycles there's just 1 active copy in the core, and with other paper structures, with the more popular structure, we have already 3 copies, and 4th one being made. So that's why this is a less common replicator variant. Moving on to the next entry, Bombus Nashi. It's a scanner, bold choice, and I welcome it, because scanners can work very, very well against certain warriors. And we can already see it here on the right side in the score table. It beats some of the Nash Equilibrium warriors very, very hard. But it's a risky strategy because itself, the scanner itself can be beaten very hard in turn, and that's what we also see. So it's a risky balance. We'll see how it works out for S. Fernandez. Here's the execution trace. Another interesting thing about this warrior is the step size is 43, which is unusual because the vast majority of nanoscanners are using step size of 5, and the Nash equilibrium is probably adapted to the step size of 5 very well, so unorthodox step size is necessary here, and we can see that the scan pattern is really good. It covers basically the entire score, or the entire core by cycle 23. So that's the power of nanoscanners. Moving on to John Metcalfe with glitch core. This is another nano replicator, the most popular paper structure, and it's a great Nash equilibrium score, 163.6. I believe it's the largest score we've seen so far. It beats some of the warriors from Nash equilibrium very hard and does not get beaten itself too hard. This paper structure, it's very, very resilient. If you optimize it well, it's very hard to beat. Typical looking execution trace. The next entry by John Metcalfe is Rogue AI. It's a 5-line clear. Also a great Nash equilibrium score, qualifies easily. And also not a lot of warriors in Nash equilibrium that can beat it. The execution trace shows again 3 move attacks and 2 decrement streams. Like the specifics of these nano clears are different each time, but the overall strategy, they often look very similar, like 3 move streams, because you have 3 move instructions in the loop, and also 2 or maybe even 3 decrement streams. Moving on to Dave Hillis. Dave Hillis is a long-time Evolver author of Red Race C Evolver. The first entry, Smith and Atrocity, is a 5-line clear. Qualifies with a margin of 2 points. Decent scores against the equilibrium. And yeah, pretty efficient execution trace, because we can see that by cycle 40 it covers the majority of the core, and all 3 move attacks are operating at faster than light speed, so the overall attack speed must be something like 2 speeds of light, because that's what you have to do to survive in the nanocore. Speed of light, which would normally be fast in other settings like 90 for NOP, it's just not enough for Nano. Okay, we have second entry by the Achilles, Sotus Grindstone, another clear. Qualifies just barely, but qualifies still. Okay, okay-ish scores against the current Nash equilibrium. And here's the execution trace. Actually looks less efficient than the previous Dave's entry because there's more core left uncovered. So I think Smitten Atrocity is a stronger entry. Moving on to Simon Wainwright. This is a 4-line clear generated with case seeded with existing warriors, I think, because this looks like a variant of 1412. Qualifies easily and does pretty well. Loses hard to a scanner, but otherwise does well. Okay, here's the execution trace. It's a two-pronged move attack, but we can see that the move attack moves at a very fast speed, so it's basically a step 4 move attack, which is unusual. The next warrior by Simon Wainwright, Voodoo Curse. It's a very interesting choice. It's a variant of Bifurcation, a quick scanner. And yeah, great choice, I think, because quick scanners can beat some warriors really hard, and we see here in this score table that it beats some existing warriors from Nash equilibrium by a very, very large margin. Okay, I need to take a quick break. I'll be back in 2 minutes. Don't go anywhere. I'll be back. Alright, I'm back. Hi Roy. The score should match the scripts, but these particular values, I've calculated them in a manual fashion. I just ran the warriors through CoreWar and then basically used spreadsheet math. But yeah, they should match the scripts. Okay, so Voodoo Curse. What I was saying is that it can beat some warriors pretty hard, but can itself be beaten very hard in turn, just like the scanners, and that's exactly what we see in the scores against Nash equilibrium. And here's the execution trace. We can see the initial scan, and then the attack at 1 speed of light. But as I was saying, 1 speed of light is just not enough for Nano. You have to be quicker than that to survive. So for quick scanner, it's as you hit the opponent with the scan instruction and guarantee yourself a win on the spot, or you don't and you're fighting from a disadvantageous position, basically. Moving on to Vogue, another long time player and evolver author. 9 DC something something. I'm not going to read Vogue's names, of course. But it's a very interesting looking warrior. 2 splits in the starting location, then 1 imp instruction, 1 split to the imp, and another kind of attacking move instruction. It's a kind of imp launcher, and you can see that it works really, really well. It beats some of the Nash Equilibrium warriors super hard, and the ones it can beat, it just tries to tie with them, because it generates tons of processes and splits to imps, and the scores really show its defensive nature, because against some replicators we can see that it's just mostly ties. Only gets beaten by a handful of warriors, and it's not beaten super hard. But we can see that it can struggle against replicator because it has no means of effectively beating them. But still, the Nash Equilibrium score 163.4 points. This is just excellent. For such a defensive strategy, it's an amazing score. And here's the execution trace. We can see that it's a very, very slow to start warrior. It spends a lot of time, basically first 20 cycles. It spends most of the time just splitting and generating processes. And around 40 cycles, it starts mixing in the move instructions, the imp starts kicking in. But it must generate so many processes that it's just very hard to beat. The next warrior by Vogue. Another very, very unusual structure. Starts with a quick bomb move, then self-split head, then move away to the imp location, and then 2 imp instructions. This is also an imp launcher and also a defensive strategy overall, but it's very different from the previous one because it's a different sequence of instructions, and we shall soon see that it works in a different manner. But looks like it has same strengths and weaknesses, because again it beats very hard the warriors it can beat, mostly clears. With some warriors it just ties, and against replicators it struggles, but still qualifies easily. Another excellent Nash Equilibrium score. Here's the execution trace, and here we see that it works in a different manner. It doesn't split quite as much. In fact, it's very, very light on the splits, and it's mostly imps from the get-go. Okay, at instruction 5, we already have move execution at a far away location, and it has this it has two streams of imps. It has the primary stream, and the secondary stream actually starts right after the last instruction of the warrior itself. So interesting stuff by Bulk. We'll see how it works in the final round. Okay, moving on to Roy Van Reen. I believe that's the correct pronunciation. Roy, please correct me if I'm butchering your name. Nashville, Tennessee. And it's a replicator, typical 5-line paper clear structure. Again, easy choice for the reasons I've already mentioned. Good Nash equilibrium score. Yeah, as you can see, Roy, it matches, my score matches the one you've calculated. 161.2 points, easily qualifies, does very well against existing warriors, not beaten hard by any of them. Let's look at the execution trace. Okay, so here's the first copy, second copy, and typically for such papers, third copy at cycle 39. And the next entry, Forbes by Roy Van Reen. This is an absolutely banger of an entry. Just look at the Nash equilibrium score. 168.3. That's an insane score. I really didn't expect that such scores were possible. I didn't really optimized against Nash equilibrium myself, but yeah, this is just unbelievable stuff. It's a 5-line clear. And yeah, it gets beaten by just one warrior from Nash, from the current Nash equilibrium, and handily beats the rest. So this is the one to look out for. This is a serious contender. Moving on to, okay, to execution trace first. It's a very efficient clear. You can see three move attacks, and one separate decrement stream and one decrement stream interleaved with a move attack. And now we move on to my entries. I've been deliberating for a long time what should I submit, and in the end I chose two clears generated with my unevolver arms race. I then optimized them with a separate optimizer. The first entry is Reptiloid Conspiracy. It's a 5-line clear. Not very impressive Nash equilibrium score. 151.2, that's not a lot when compared to what we've seen before, but my strategy with this is different, because the Nash equilibrium score, you don't need to beat it super hard, you just need to reach 146 points threshold for qualifying, and instead I was optimizing for resiliency against novel threats, against out of distribution warriors, trying not to overfit on the benchmark set. Here's the execution trace. Again, 3 move attacks and 2 decrement streams. And the next entry, Reptiloid Supremacy. This one is a bit more interesting. because this is a 4-line clear with a dot bomb. I think this is a super underrated structure. John Metcalf, if I remember correctly, had some Nano warriors like this that use dot bombs to attack. I think it was called Valhalla. And yeah, really underused structure that has great potential. Moving on to execution trace. Here's the 2 move attacks, and we can see it's a kind of a interesting structure. It's a trick we've seen in other warriors, where first it moves the dot bomb, and then it moves it executes instructions, it executes an attack instruction that decrements the location of the dot bomb, use it as a reference to attack another location. And dot bombs are generally deadly because why move some instructions from the middle of the core, which may not be a dot zero, when you can move dots and basically guarantee yourself a kill if you hit the opponent. Okay, so that concludes the overview stage. Here's a table with all the Nash equilibrium and zero diagonal Nash equilibrium scores of all the participants. We can see an absolutely insane score by Roy, and the most interesting thing about it, it's just not the Nash equilibrium score that is good, it's the zero diagonal Nash score that is good too. And this is important because I think many players decided to optimize against Nash equilibrium directly, and in my opinion, this is not a good strategy because Nash equilibrium is so tiny that you will overfit on it if you optimize against it, and your score against other warriors will suffer as a result. And we can see this phenomenon in this table where some of the warriors beat Nash equilibrium really hard, but have not so great scores against zero diagonal Nash equilibrium, which includes more warriors. Yeah, but Roy's score, it just dominates everything we've seen so far. Moving on to the second part of the table. In the bottom of the table, we have Yes Fernandez and Dave Hillis, who barely, well, okay, Yes Fernandez actually qualified by a reasonable margin, and one of Dave Hillis' entries barely qualified. And Steve Gunnell, unfortunately, misses the qualification threshold by just a little more than 1 point. So Steve Gunnell, Anderson, Telkar, and Draginator did not qualify, and Kurogi actually did qualified with just 1 entry. Okay, so this actually concludes the first stage, and now we shall move on to the second stage. You can see an empty table here because I don't know the Nash equilibrium yet. I decided not to spoil the fun. I don't know the results myself, so I'm going to calculate it right now. Let me switch. Okay, let me switch to a terminal. So what I'm going to do with this is I'm going to add all qualified players one by one. I'm not going to do it at once because that would be boring, and to have more drama and suspense, I'm going to do it player by player. Starting with S. Fernandez, and the order of players will be from the lowest zero diagonal Nash equilibrium score to the highest. And this does not affect the final standing. The result would be the same as if I was to add all warriors at once. This is just a way to have more interesting tournament. So what's going on here is I'm using a non-linear programming solver to find Nash equilibrium using a quadratic programming formulation. And here's the equilibrium with S. Fernandez warriors. Here they are. I've marked all warriors sent to this challenge with an exclamation mark. So yeah, 2 warriors by S. Fernandez make it to the Nash equilibrium as expected, because if you have a warrior that has a score higher than the score of the Nash equilibrium against itself, then you would enter the Nash equilibrium. Next we have Dave Hillis. Okay, Dave Hillis puts a warrior on the board, but only one actually. Sawtooth Grindstone does not make it, and Smith Atrocity does, and it does so at a 5th position at 8% of the equilibrium. One of the S. Fernandez warriors, Bombus Nash, is still holding on, the other has been pushed off. Okay, now we are adding Kurogi. Great result for Kurogi. Gerlach arrives at 4th position at 8% of the equilibrium. Pushes off one of S. Fernandez's warriors, but the other gets right back in, and Dave Hillis' warrior barely hangs in there. So very strong performance by our newcomer Kurogi. Next we have Simon Wainwright. Very strong result by Simon, Ultimate Balrog, landing at 4th position at 6.69% of the equilibrium. Wood occurs lands at 11th position with 4%. Karlach has been pushed down to 12th position with also a little more than 4%. And looks like Dave Healy's warriors have been pushed off the equilibrium. But S. Fernandez, Bombus, Nashi holds. Okay. Moving on to lane. The equilibrium actually has more than 30 warriors, and it doesn't even fit in the terminal screen. I made the output limit intentional. I limited it to 30 warriors, but this time it's not enough anyway. Karlach still holding very, very strong at 7th position with 5%. Bombus Nashi moves up the ranks with 4.46%. Woodacres and Ultimate Belrock by Simon Wainwright still hold pretty well. And the new entries I've just added by lane looks like one of them did not make it, and Gazette did make it at position 15 with 3% of the equilibrium. Two of Dave Healy's warriors finally make their way back. And now we move on to some much stronger stuff. First, Vogue's two unique imp launcher warriors. Okay, you know what? The Nash equilibrium is getting longer than 30 entries. Maybe I need to change my code to actually display the entire equilibrium. So I'll change it in a second. But Simon's Wainwright warriors move to the dominant position, 7th and 8th places with 5 and 4%. Lane's entry is doing pretty well, but only one of them. Carlos Kurog is doing okay. As Fernandez, Bombus Nashi is still holding. And two of Vogue's warriors, they don't do as well as I expected. And two of Dave Healy's warriors still holding on. Okay, now it's time to add John Metcalf. Let's go, that's starting to get really interesting. Interesting results. Karlach moves to the 2nd place with 6.5% of probability. John Metcalf's two entries occupy 8th and where's the second one? Okay, here it is, and 12th place. Next we have Voodoo Curse, Ultimate Belrock, one of Vogue's entries, Scanner by S. Fernandez, and finally Gazette and Smith and Atrocity. All right, now the real interesting stuff starts. What do you think? Should I put my entries first or Roy's entries first? Because I think these are the heavy hitters. My entries have a moderate scores, but they are quite resilient, and Roy's entries have insane scores, but we'll see how it works out. Okay, I'm not going to switch. Here we go. Oh, the reptiloids dominate the equilibrium now. The reptiloids rule with an iron fist. That's a large chunk of probability. 18% and 17%. Next we have Smith and Atrocity by Dave Hillis, moving up the ranks. Karlach by Kurogi. You know, Karlach is doing consistently well throughout all the Nash Equilibrium updates. Next we have an entry by Vogue, and that's it, because the Nash Equilibrium is now has just 19 warriors, down from more than 30. So we have, yeah, looks like many authors have been pushed off. We have me, Dave Hillis, Kurogi, Vogue, and that's it in the equilibrium. That's surprising. John's entry's been pushed off and are nowhere to be seen in the top 30 spots. Okay. And now is the moment of truth. Make your bets, ladies and gentlemen. Will Roy be able to take it? Will he be able to defeat the evil reptiloids? Here we go. Unfortunately, he doesn't. And did he even make it to the equilibrium? I don't think he did. My entries occupy the top spot. Next we have Smith and Atrocity by Dave Hillis. Then we have Karlach by Kurogi, still holding on. One entry by Vogue. Glitch Core may be a part of equilibrium, maybe not, just around 0%. And Roy's entries are nowhere to be seen, unfortunately. That's it. That's the result. And let's just quickly... There's not a lot of calculate, because my entries obviously take the first spot by probability. That's more than 30% of probability. Next we have Dave Hillis with 9.9%. Only one entry makes it to the Nash equilibrium. Kurogi, again one entry with 4.3%. And Vogue, one entry with 2.2%. So that's it. My entries take the top place, and I save myself 100 bucks because I don't have to pay out the first prize. And Dave Hillis takes the second place prize. Congratulations to Dave Hillis. And just to be sure, let's calculate the Nash equilibrium in a different manner. Just give me a second. I need to copy the data. Okay, let's see how the other calculation method does, and does it find the same equilibrium or not. This method is based on mixed integer linear programming. It's even more precise than quadratic programming, and I can start it with random initializations, and this way we can see to what equilibrium it converges. Is it the same equilibrium or not? And the way it works, it builds the equilibrium incrementally, starting with a single warrior, then it adds a second warrior that is the best reply to the first warrior and recalculates the equilibrium. Then again, it finds a remaining warrior that is the best reply to the Nash equilibrium attained at the previous stages, again adds it and recalculates, and so on, and this happens in a loop until we run out of best responses outside of the equilibrium. And as you can see, this is a slower method, so I've been using it as just as a backup. And without incremental construction, I think I can calculate a Nash equilibrium for around 60 warriors. And that's the limit because the mixed integer programming problems, they get harder and harder, and beyond 60 warriors, the solvers just take too long. Okay, here's alternative equilibrium. Looks like... Okay, let's check. Is it the same equilibrium? What? It's a different equilibrium? What? Are you serious? Wow, that's very surprising. I think that's a different equilibrium. But the results still hold. My interests are still first, and Dave Hillis' single entry is second. I really didn't expect this. I was absolutely sure that we'd get the same equilibrium. Okay, let me save this first, and I'll try again from another random start. I never had this happen before. Okay, another one done. I think it's the same as before. Yeah, the same as the mixed integer linear programming method from before. Yes, 18 words in total and identical scores. Oh, I see what the problem is. I think I see what the problem is. Let's take a look at the equilibrium found by the quadratic programming method. It is actually slightly off equilibrium, because look at the scores. All the scores are the same except a couple of them. And in a true equilibrium, all scores should be exactly the same, because it would not be an equilibrium otherwise. And what happens here, I think, is the problem is just too difficult for the quadratic programming approach, because quadratic programming can find an equilibrium if it exists, but it's not guaranteed to find it. Because we have a non-convex quadratic program, and interior point method, it just can't guarantee the global. It can guarantee a global optimality of the solution. So what we have here is an approximate equilibrium with some scores just slightly off. This also has never happened before. Quadratic programming has worked very well for me in all my previous runs. Looks like we have a third result from the mixed integer linear programming method. Again, 18 warriors. Let me check if it's the same exact result. Yes, this is the same result as before with the alternative method. So we don't have a second equilibrium after all. It's just the problem being too difficult for the quadratic programming approach. But mixed integer programming approach, on the other hand, if it finds an equilibrium, then it's exact. So we have to go with these results instead. So this is the final standings. But the outcome is exactly the same, because my warriors hold the top position and Dave Hillis comes second with 5.44%. Then comes Vogue with 1 warrior, S. Fernandez with 1 warrior, and Kurogi with 1 warrior. Okay, so that's it. That's the final standing. I will make sure to run the equilibrium computations more times to really make sure that we don't have some hidden spurious second equilibrium. But as far as prizes go, that's it. That's the result. Congratulations to Dave Hillis, and congratulations to anyone who made it past the qualification stage, because we really did push the equilibrium a lot. We didn't just beat it, we just blew it open. So I'm really happy with the response I got with so many entries. I think we had a banger of a tournament with so many players and so many different strategies. And that's it. I'll be ending my stream now. If you participated, thank you very, very much. Thanks a lot to John Metcalf. He helped me out a lot with this challenge. And if you submitted an entry to this tournament, great job. Alright, just quick catching up on chat messages. Yeah, interesting results with the new equilibrium, because Imp Spiral score very well. Pass of the Mountain Hare by John Metcalf is at 4th position. It's a true Imp Spiral, and that's not too surprising really, because they were out of favor for some time and no one optimized against them, and all the new warriors optimized against the Nash equilibrium or some top fraction of CoreWar tool. They just went optimized against Imp Spirals, I think. Okay, Roy asks, what was my strategy? The strategy was just a careful selection. I had a pool of candidate warriors, and the way I selected 2 final candidates is I've been testing them against my other unpublished warriors to verify what kind of performance I get on potential novel threats out of distribution, because you know that's similar to machine learning. You optimize on a train set, but somehow you have to make sure that your model works out of the distribution. And that's kind of what I did. I selected my warriors by cross-validating them against a large pool of unpublished warriors that I had. And after that, I selected specifically by the amount of warriors that can potentially beat me. So I selected the final candidates by minimizing basically my chances of getting beaten by anything. Yeah, John certainly has 1 warrior in the equilibrium, even though it's not his entry. Okay, so that's a wrap for today. Thank you very much for watching, and I'm really floored by the response I got, and I hope this won't be the last time. I hope that I'll do this kind of challenge again. So stay tuned. See you next time. Bye.